Hello and welcome to this tutorial on how to make a 2048 game in Construct 3. So let me just show you what the end result is here. So you know this game. You just have to double the tile every time. And then eventually, if you do it right, you get a tile called 2048 and then the game is over. But unfortunately, most of the times, the entire board will fill up with tiles and you will have no further combinations, and then the game is also over. So how do we make this in Construct 3? Actually, there are only two layouts in this game. The main game layout is this one here. This layout contains a number of layers. The HUD layer takes care of the upper part of the game here. The score and the best score, which are updated on every tick. The dialogue layer just shows the dialogue. It's hidden and shows whenever the dialogue needs to appear. The tiles layer is where all of the tiles are spawned at runtime. And the grid layers take care of the grid. It consists out of a background and in the foreground 16 placeholders. Let's see here. 16 placeholders. They are needed to have reference when a tile has to move on the screen when the screen is swiped. In order to keep track, a row and a column instance variable has been added to that placeholder. All tiles are added to a tiles family. Let's look at that one here. That's because they share a common behavior. They all have a row and a column instance variable to keep track of where on the grid they are, and the value instance variable shows the current value of that tile. The will upgrade and handled flags are there to check whether the tiles have to move to which tiles will reconcile into another tile with double the value. All texts also have been grouped into a family. These texts are pinned to the individual tiles using the pin behavior. To keep track of the tile they are attached to, they hold a reference UID actually. You can see that there. So in the second layout you have all of the others here. This layout contains all of the possible tiles in the game and all of the possible tile texts. They have both been added to the respective families, as I showed earlier, because they have common behavior. Alright. So if you now go look into the event sheet here, above here there are a number of variables and a constant. These variables are needed in the logic here. Let me just collapse this so I can have I can give you an overview of the functionality here. There's a grouping of some base functionality. So on every tick I just update the scores. The label score and the best scores are the scores on top in the HUD, which are updated every tick. And then at start of the runtime, start of the layout actually, we spawn a 2 and a 4. That's actually a standard way of starting the game. As you'll see in a minute, the spawn tile will pick a tile, an open tile at random. So we spawn a 2 and a 4. So we have to make sure that the dialogue is hidden, of course, and the score is reset to 0. And then we'll get the best score, which is using the local storage plugin, and then we can check check if the item exists, and it will result in an on item exists or an on item missing event. And that's what you see here. On best item score exists. If it exists, we load the best score, and if the best score is missing, we just initialize it. So this game uses the touch plugin to detect swiping to the left, to the right, up or down. In order to evaluate this, we need to know the starting X and Y and the ending X and Y, and that's what we're logging here on touch start and then touch end. So that's a bit the basic functionality what we do here. Now on touch end, if we expand further on this functionality, we have to compare the coordinates. So we first see if the touch is within a tolerance. So the tolerance, if the touch is not within the tolerance, it means that we're not dragging sufficiently to the left or to the right. It's hard to determine if the user now dragged far enough. That's why we use a tolerance. So if it's within the tolerance, so the distance between x, starting x and ending x is bigger than tolerance, or the distance between starting y and ending y is bigger than the tolerance, then we're considered as dragging. And then we'll check if we're dragging horizontally using the same variables here. And if we're dragging horizontally, then we're checking if we're dragging to the left or dragging to the right. And depending on how we are dragging, we call a function, which we'll discuss in a minute, called perform drag with type left, right, up, or down. That's it. Now let's collapse this. Collapsed, and now we expand on the checking. So the checking will check the grid and see if there are open spaces, and we'll get values, and we'll get also the possibilities. So there's a lot of functions here. I'm a really big fan of functions, by the way. They keep your code nicely and neatly together, and you can call them wherever you like, multiple times if you want to. So nothing but good stuff. The function getOpenPlaces effectively fills an array called open spaces. This is the array, and we have to first initialize that array. So 0x, 1y, and 1z. That's actually a way to initialize the one-dimensional array. And then we have to loop through the columns and the rows, just a for loop from 0 to 3. And then we use the isPlaceOpen function we also created with that row and column loop here to check if the place is open. And if that is so, we just push it onto the array. And we also return 1 if there were open spaces found. So this is the isPlaceOpen function we used earlier. This function will result a 1 if a space is still open. So we start off with a 1 as a default, and when the pick succeeds, we reset it to 0. So that means that if the tile is found, then it is returning a 0 actually. The getValueAtCoordinates is a little helper function that will return the value of a tile at a certain coordinate. That's it. If there's no tile, the value is default is 0, so meaning no tile. And every other case, the value of the tile will be returned. So that's 2, 4, 8, 16, etc. And then this function rMovesPossible will return 1 if there's any move still possible. This can be used to tell if the game is over or not. So to do this, we need to loop through all of the columns and the rows. So we do that here with a little for loop. And then we save some local variables to make our life a bit easier in the checking procedure here. So we're checking down, the tile below is empty or has the same value as the current tile. And then a move is possible, of course. What we do here, and then we check up, and we check left, and we check right. That's always the same thing. For example, checking down, we go to the current row -1, to check up the current row +1, etc. That's the way it works actually. Great, so that's some functions we can use to check open places and stuff like that. So then we go to the spawning bit. So there's a function called spawnTile in which you can pass the tile to spawn. So that would be a 2, a 4, an 8, etc. That's what we used in the on the start of layout to spawn a 2 and a 4, for example. So to spawn a tile, the function will spawn a tile with the value passed as a parameter at a random place. So we first check if there are still open places, and as you remember, in this function we'll also fill the open spaces array. And then we randomize the place to spawn by choosing a random entry in this open spaces array. You can see it here, set chosen number to the floor of random open spaces.width. So open spaces.width is just the size of a one-dimensional array. So we parse the value into a row and column. That's because what we pass into the open spaces array is a concatenation of the row and the column. So you reparse it out of it to the left part is the row and the right part is the column. And then lastly we just spawn a place at a tile. So the tile we want to spawn, the row and the column is passed along to the next function called spawn tile at place. And that's this one here. So the tile we need to spawn, the row and the column coordinates. So the function spawns a tile at a certain coordinate, and the tile value passed as a parameter along with the row and the column coordinates. So we select the placeholder here and we create the tile. We do that with the create object by name functionality. So after picking the last created tile, we just set the row and the column, and we create the text to go along with it, and we pick the last created text at that time. We set the reference and we pin it to the tiles. That's it. So now that's the way to spawn. And then comes the interesting bit, being the interaction. So let's skip this for now and first do this. So the perform drag, if you remember, the perform drag function has a parameter called the drag type, and that could be left, right, up or down. So what it does, it fills a dictionary called tiles to move. And once the dictionary is filled, then the tiles to move will be moved into their respective places actually. So first we clear the dictionary to move the tiles that will be moved, and then we initialize a semaphore that denotes that a move operation is happening. So once a move operation is happening, we don't want a move operation to start again, and that's why that flag has set to 1. Part of the logic is marking some tiles as handled, as you see in a minute. We do that because they won't reconcile twice. Reconciling is a process of removing 2 of the same type of tiles and then adding a single one which is double of those 2 tiles. But those handled flags as an instance variable of that tile need to be reset first, and that's what this reset handled function does. So then we have logic for every possible drag type left, drag type right, etc. So let's see here how the drag type left works. So we need to determine the blocks to move. To do this, this depends on the way of dragging. For drag type left, we loop through all the columns, not taking into account the first column, because it can't move. So we do this with a for loop from 1 to 3. And we pick all tiles in that column. Then for each tile in that column, we perform the same logic. So we initialize a flag that denotes if a place has already been found for the tile in question. So for each tile, I go 1 step to the left until there is no opportunity to go to the left. For example, here we do that for the inner loop. That's a second loop, from the loop index of the outer loop -1 to 0. So we go to the left gradually. So while we can keep on moving to the left, so no place was found yet, we keep on checking. We do this check here, found place to move is 0. And if the spot is still open, we can move to that column. And we check that using the get value at coordinates here. If it returns 0, it means we can still keep on moving. And we just add the tiles to move here. The tiles to move dictionary eventually, and we set the column instance variable of that tile to that inner loops value. So that we loop again, and if the column has the same value, we can also move to the column to consolidate that tile, but we can't do that if the tile has already been marked for consolidation by another tile. So it can't consolidate twice. So that's what happens in the else branch here. So if they get the value with coordinate equals the same value, and the tile has not been handled yet, so we created a little helper function, is tile handle, that gives a 1 for a handled tile, a 0 for a non-handled tile. So if it's not been handled yet, what we do is, okay, we add it to the tiles to move dictionary as well. We set the column. We also set the will upgrade flag instance variable actually. And after that we mark it as handled. So next time it goes into the loop, it won't evaluate this else branch anymore. So and finally, here there are no more options to move to the left. So we mark the found place to 1 here, the one who initialized here at the end. So at the end of the game here, there are tiles to be moved. So if it's not empty, the tiles to move dictionary, we loop through each key, and we actually use the move tile to coordinate functionality to move the tile to that coordinate. And we do the same for right, down, and up, very similar to what we did here. So the move tile to coordinate actually, what it does. Let me just go back a bit up here to this one. Once the tile has started moving, let's do the combination, and it started moving using the move tile to coordinate function, we add 1 to the moving tiles, this one here. And here we check if it's moving, we also subtract from the moving tiles. This logic here on move to arrived is execute when a tile arrives at its place, but we first need to check if there are tiles moving. That's what we do here, yeah. And then we subtract 1 from the moving tile counter. That's done because at any given time 1 or more tiles could be moving at the same time, and this logic needs to be executed only once if all tiles have been moved into place. So when a tile starts moving, it increases the moving tiles left counter, and here it's subtracted again. So here it's increased and here it's subtracted. So if there are no longer tiles moving, so it's the last time a tile arrived at its place, we deactivate the moving flag, because otherwise the logic would be executed for every tile that arrives at the destination, and this flag is enabled when the swiping operation happens. Reconciling all the tiles that require reconciliation. So reconciling is the tile destroying 2 tiles that overlap and spawning a new tile at the same place with a double value. That's done in the reconcile tiles function, which we'll talk about in a minute. And finally, we spawn a new title at a random place. The function is asynchronous because the check in are moves possible, which we do here, require all tiles to be at their place before checking them. So then we will wait before the action for previous actions to complete. So if there are no moves possible anymore and the dialog is invisible, we will show the dialog anyway with success 0, which means it's a game over and not a congratulations. So all this is initiated by the move tile to coordinate. The only thing we will do here is add a 1 to this little counter. We set the move speed of the tile, and we actually move it to the placeholders x and y coordinates, which we pick here. This is the reconcile logic. Reconcile tiles at coordinate will reconcile the tiles. The function reconciles 2 tiles of a single value into double that value. And when reconciling 2 tiles, the perform drag function will have to give both the same coordinates. So we can start picking them. So that means once the perform drag has finished, all of the tiles from all of the tiles and the grid, there will be 2 tiles that have the same row and column combination, and that's the one we need. So we will be picking 2 tiles here, and with this row and column, and then we only retain one of the 2 in our selection. So we determine the new value of the tile that needs to be replaced here. We do ×2, and we increase the score. If the score is better than the best score, we just update the best score, and we use the local storage plugin to save the best score when it changes. That's it. And if the new value is 2048, hey, we're done. The game is it's a successful game, and we also show the game over dialog. So after handling the score, the 2 old tiles can be removed, and the new tile with the double value can be spawned in its place. So we pick the 2 tiles, and for each tile we destroy the text and we destroy the tile itself. And we create a new tile with the spawned tile at place, with the new value being the double at the same row and column coordinates. And then there are still some helper functions here. Markers handled will set the handled flag for a row and column combination. Reset handled will set it to 0. And then there's a little helper function that just tells if the tile is handled or not. It sets default to 0, which means that's only when the tile is picked here, it will return the value and do the tiles.handled, and when overwrite the return value. That's it. And finally here we have the reconciled tiles, which actually just selecting all the tiles that needs to be upgraded with a picking operation, and for each tiles we can call the reconcile tiles at coordinate functionality here. And finally we have the dialog. We show the dialog. By showing the layer, we set congratulations or game over, depending if we pass 1 or 0 as success. We set a marking that the dialog is visible or not, and we activate the buttons on the dialog by activating the dialog interaction group here, which is this one. So on left click on the retry button, we restart the layout. So this is activated here on show game over dialog. And in the hide game over dialog, we just hide the dialog layer, reset the flag, and we also deactivate the dialog interaction. That's it. So basically this is all of it. This is the way you make a 2048 game in Construct 3. As always, please like and subscribe. For those of you who would like the full template code here, I will leave a link to the Syrah store in the description of this video, so you can pick it up there as it is, as I explained it here.